let's start. Let's introduce Torsten.
Yes, let's introduce Torsten. So the nice thing with Torsten is he has not been giving a talk for 10 years. So it's almost as if it's new, right?
Yes, it is.
Nice. And his children are quite jealous of the fact that he's here in Rotterdam while they are at home. And to make it even worse, they can't even play with their own Lego. I want to have a big round of applause for Torsten.
Thank you. Okay, let's reset the timer and then start. Yeah, ahoy. My name is Torsten Schönebaum. I'm working for Sage, which is a business software company working globally. And I'm working on their accounting product, which is a cloud software for small businesses. But I won't talk about stuff I'm doing at work. I will talk about stuff I do at home. And let's start with a quote, because I've heard that using a quote at the beginning of a talk is great. Friedrich Schiller, a German poet and philosopher, once said, "Man only plays when in the full meaning of the word he is a man, and he is only completely a man when he plays." Before someone calls the code of conduct team, remember Friedrich Schiller lived in the 18th century. Equal rights weren't a topic back then. And probably the translation isn't the best. You should read it as human only plays. And what he means is humans gain their cultural abilities during childhood when they play. And they even improve their cultural abilities further later in their life while playing. Playing is something crucial for humans. You learn new things, you get creative while doing something without having a direct goal or target. And if that is so, then it is a great excuse for getting a rather large Christmas present, a box of Lego Mindstorms Education. And it's even a better excuse to get another box accompanying. So what's in the box? You get lots of Lego parts, of course, and maybe the most important thing is you get the Lego EV3 brick, which is basically a computer. You get 3 motors, 2 large ones and a medium one, and you get a bunch of sensors. You get an ultrasonic sensor for measuring distances, quite precise, up to the centimeter. You get an gyrometer, where you can measure angles. And you get a color sensor, which you can use to detect colors. So you can sort Lego bricks, for instance. But you can also measure reflected light, which is useful when you want the robot to follow a line. And you also get 2 touch sensors, which Lego calls touch sensors, but actually they are just buttons, so you can either press them or not. Yeah, let's build a robot. You can see the robot on the pictures, and I've brought it here. So building a robot is also something which is trial and error, which is playing, because if you do not follow instructions, you have to try things out. You have an idea what the robot could do, and then you start building, and it either works, but most of the times it doesn't work. So this robot here took 4 tries or so, until it was in a shape that I thought, okay, that's something I can use. So I'll put it down there for later use. What can robots do you build with Lego? Basically anything you can build with Lego. There are some restrictions. The motors are not too powerful, so you probably wouldn't be able to move a boat with it. But you can build a robot that just moves around. You can build a robot that follows a line. You can build a robot that follows a line and then avoids obstacles. You can build a robot that navigates a maze. Actually, there is a contest for students, which is called EuRuKo. No, actually, it's not just for students. It's called EuRuKo, and they meet, and it's a great competition worldwide, and it's really great. And they are building robots where the robots have to rescue marbles from a maze. And that's amazing. Let's come to the computer, because we are at a Ruby conference. We don't want to talk too much about Lego. The computer has a CPU which is ARM-based. It has 300 megahertz. You have 64 megabytes of RAM, which is plenty for a tiny robot. And you have a micro SD card slot and so on and so on. It's probably not that interesting. There's also a display, but it's very small. Yeah, you won't see it. And now let's have a first demo. I have to start something on a robot, so I've written a program in MRuby. And no, sorry. Let's see what it does. Let's have this slide. Let's have this browser here. So this is actually a web page which is loaded from the robot. So this is running on the robots. You can see the measurements of the sensors. So this is the ultrasonic sensor. Let's try something. Does the value change? Yeah, it does. Great. So as you can see live. Now, could I please see the robot on the screen? Ah, great. And now I can control it in my browser. And it even has sound. Yeah. Okay, let's try to move it. I should probably stop the robot. It shouldn't fall down off the stage. Okay, and I have to move it back because later on there will be another demo. And I have to do something for that later demo. I forgot to remove the cap because there's a pen. Okay, so what can you do to program this computer? From Lego you get the EV3 education app. You can download it for free, and then you can program the brick with it. It is a graphical programming interface based on LabVIEW. It's very intuitive. You have live debugging, you have data logging, and you also have build instructions. So if you have no idea what to do with the parts you have in your set, then you can open up some build instructions by Lego and you can build a robot and it will actually run. This is great, but it's very hard to create complex programs. It's actually impossible to create something you have just seen. You cannot build a web service on the robot using that software. And the application itself is so slow and hard to operate. So it's no fun at all for an experienced developer to use it. It's maybe not even fun for students because the application is just so slow. So I looked for alternatives. What can I use else? There is a make code environment for this robot. For anyone who doesn't know, make code is from Microsoft. It's browser-based development environment, similar like Scratch. You can use graphical programming with that, or you can edit text files in your browser. And it's using TypeScript. So you have JavaScript. And as you cannot have live debugging in your browser together with the brick, it has a simulator, which works most of the times, but sometimes it doesn't. There's also Lignite, which I didn't try out. It's a Ruby gem, so Ruby, yeah, I was happy. But it runs on your own computer. It doesn't run on the brick. And it produces bytecode the default EV3 operating system understands. But I wanted to do something different. I wanted to run Ruby on this brick and not on my machine. So I was looking for other options, and I found EV3 Dev, which is a Linux distribution for this brick. It's Debian-based, and you install it on a micro SD card, and you do not have to flash the firmware, which is great because if I'm fed up with this stuff, I can just remove the card and can give the set back to my kids, and they'll be happy, and they can use the graphical environment by Lego. EV3 Dev includes drivers for most, if not all, the peripherals. Definitely the sensors and motors which are chipped in the default set are supported and are working. and which is maybe most interesting, it has an SSH server, so I can get a console on the computer there. So I wanted to try MRuby. Why? Yeah, because obviously the logo of MRuby looks like a Lego brick. Also, I thought that this is just a small computer. It doesn't have much memory. It doesn't have a big CPU. So I use a Ruby implementation that is not that big as well. Because MRuby, the M could stand for different things. It could be embeddable Ruby. It could be Ruby for embedded devices. It could be mini Ruby or whatever. But in the end, it's just an alternative interpreter for the Ruby programming language. It does not implement every class and method you know from C Ruby. So you have to watch out what you do. But for that reason, it also has a much smaller footprint. So it needs less memory. It probably even runs faster for some things. And this is something which I thought is desirable when running this Lego robot. So I tried to install it, try and fail, play around. And my initial thought was, okay, this is a Debian-based distribution, so apt-get install MRuby should work. And actually it does. Yeah, so I was able to put hello world, and I got hello world. But as I might mention, the CPU doesn't support floating point operations well. So I was eager to use a rational class so that I can use integers as often as possible. And as you can see here, the rational class isn't present. Oh, bad. So I cannot use the Debian distribution without changing something. Now, MRuby doesn't support Ruby gems. Why? So MRuby is a library that is compiled. And you can add this library into your program. If you're using a library and you statically link it against the program, then you cannot easily dynamically load code later. So all the gems you're using have to be compiled into the library. And for that reason, there are no Ruby gems for MRuby, but MRB gems. They are a bit different from the default Ruby gems, and you define them, that you want to use them in your build configuration. So first, you fetch the MRuby source, and then you have your build configuration. This is just an example, which is including some gems. I left out the rational gem, but there's a rational gem as well. And then you compile it. Just call mini-rake. Yeah, you compile it, and then you grab a coffee. You maybe even prepare pizza and eat it. I don't know. I stopped the operation after 1 hour, so it just takes so long on the robot. Oh, terrible. But there's an easy solution for that. You can cross-compile applications for that robot. The very nice EV3 dev people provide a Docker image for this. So you just have to boot up a Docker container on your machine, and then you have to install some packages from Debian, Ruby, JIT, and so on. And then we again adjust the build configuration a bit. Notice the cross build here. And then we need to adjust the commands a bit so that the compiler is found that we want to use. And then there are some gems defined. And then, yeah, it actually builds. So I've written some scripts I use to get into the compiler shell. And this actually builds MRuby, MIRB, which is IRB replacement running MRuby, and MRBC, which I will talk about later. And it also builds a library called libmruby.h because it's supposed to be statically linked into applications. And then I have to copy the binaries I've built on my machine to the robot using SCP. then I can execute, then I can SSH into the robot console, and I can run my commands, and as you can see, Rational is actually working now. And that's great. Yeah, one step further. Yeah, I already was happy at that time, and now I have to start something on a robot because it takes a bit of time. Maybe could I see the robot again? Ah, great. So you can see it's doing something. It's moving around. There is something turning down, and later it will be turning up again. And this will take about 10 minutes, so please switch back to my screen. I'll let it run, and then let's see what it produces in the end. Can I get back to my screen, please? Yeah, great. So I already was happy when being able to build MRuby on my host and then copy it to the robot. I could actually run Ruby programs on the robot now, but I also wanted to improve things a bit further, and I wanted to try things out. As I have mentioned, MRuby is a library you can compile into your own applications. So what if I create an application just for my simple Ruby script? This is possible. So MRuby works with bytecode. The MRuby interpreter creates bytecode from your Ruby code and then executes that bytecode. And there's also a tool that creates that bytecode and then writes it as object into a C file. And you can then use that C file with a bit of boilerplate code to build a binary from your Ruby code. So the boilerplate code is just, oh, I didn't count it, 15 lines of code or so. Really easy. Just get an MRB state, then execute your Ruby bytecode, which is included here, and then print an error if there was an exception, and close the state if there was no exception, and that's it. So pretty easy. Compiling the code is a bit more complicated, but it makes a lot sense to automate this. So I have a wake file with some rules which produce the boilerplate code for each Ruby application I write for the robot, and which also compiles this into binaries then. So now I'm able to produce binaries, but how do I use the motors and sensors in that robot? So EV3Dev uses the sysfs system on Linux for the communication with the user space. That means for each attached sensor and motor, there is a directory in this class. And in each of those directories, there are files which contain sensor values, motor states, and similar information. And if I want to use a sensor or a motor, then I just have to read from files or I have to write into files. Pretty easy. MRuby can do this. Yeah. So there's an MRuby IO, and IO has read methods and write methods, and this is working very well. So for example, if I want to get the distance from the ultrasonic sensor, then I first need to specify the sensor I will be using. This is just an example. You probably should use a more elaborate method to get that path, but in the end, you write a mode into a mode file, and then you read a value, and that's it. Now I have a string. I could convert it into an integer, and I could use it then in my program. For moving the motor, you can do something similar. Just read the maximum speed of the motor, and then write the speed you want to use into the speed file, and then send a command, run forever. And I suppose every one of you can guess what the motor will do if I send this command, until I send a stop command. Yeah, so now I can use the sensors, I can use the motors, but I do not only want to write one program for that robot, but I want to rebuild the robot so that it does different things. And then I want to write a new program for it. And I don't want to repeat all the code I've used to access the sensors and motors and stuff. So I created a MRuby gem on my own. And this is actually very, very easy. You just need a rake file in a directory that contains a specification for your gem. So you define dependencies for other MRuby gems there. And you can even define build instructions for the C compiler and for the linker. So if you use a library in your MRuby gem, you can find it as well. You can define it as well. And then you put your Ruby files into a directory named MRuBylib. You put your C files into a source directory. And then you go to the place where you're building your own Ruby programs and modify the build configuration and reference your own gem there. And then you can use it. So for moving the robot, I can get a motor instance by calling ev3 motors, and then I need to specify the port on the robot. And I have a movement controller which I can use to move the robot by a specific distance. So when I know how large the wheels are, then I know by how many turns of the wheel the robot has gone how far. And I'm using that here. So the wheels are 173 millimeters, not wide, circumference. Thank you very much. Have a circumference of 173 millimeters. So the motors count their rotation, and I can use that to move the robot by a specific distance. I can play sounds, as you've heard. I can even switch on the LEDs which are in the brick. There are 2 different LEDs with 2 different colors, so you can produce green and red and everything in between. And I can use the sensors very easy, so I can print the sensor values. There's even a formatted value method so that I get what you've seen here. So this is actually coming from the robot itself. It's not produced in the JavaScript here. And that's very nice. So what was difficult while developing this MRuby stuff? It was not always easy to understand which method I know from CRuby is supported in MRuby, but there is an API documentation I could use. And it was also very, very convenient to read the source code of MRuby, because even for me, who's not very familiar with C, it was possible to read and understand what happens there. What was difficult as well is, in my gem, I'm using different classes for the sensors, for the motors, and in the end, I ended up with lots of classes, and it just didn't fit into one file, and I created several files, as I'm used to in my normal day-to-day CRuby programs. And in the end, it didn't work anymore, and I was wondering, what's happening there? The reason is Lord order is important at that point, and the class just wasn't defined when it should be defined. I ended up prefixing some file names with A or something, so that they get loaded into the order I wanted them to. So nothing really important, but my advice would be to just use smaller MRuby gems. So I probably should have created multiple gems, one for the sensors, one for the motors, one for the other stuff on the brick, and then just one gem which combines the other gems as dependencies. What was difficult when running MRuby on the robot? So it's actually working quite well. There are some issues that the robot is too slow. Not too slow in moving, but too slow in recognizing changed sensor values. But this is probably something which isn't my MRuby's fault. After all, the CPU isn't that fast, and maybe the sensor isn't as fast as well. So you just have to watch out for it, but everything else is fine. What could I do to improve this further? So what do I want to do? With what things do I want to play? I want to play with concurrency. So for example, there are some buttons on the brick, and I want to have an action triggered when I press a button without blocking the program while waiting for a button press. This is something not very easy to implement in MRuby at the moment, or at least I didn't find a way yet. And I also want to use the display, although it is very small, but it would be nice to be able to use it. But it is using a Linux frame buffer, and I need C code to read and write to that frame buffer, and that is something, I wasn't up to yet. Yeah, so another demo. So the robot has finished. Maybe can I have the robot on screen again? Yeah, great. So it has finished. Let's see what it did. No, it's probably better here for the camera, and then switch back to the screen, and then here for the audience. So I have a conclusion. Playing around is fun. You can get quite far. If you have an idea, try. And maybe you're up to bring your own Lego set next year, and we have an EuRuKo Cup. Let's see. Thank you very much.
Come with me, Torsten, please.
Thank you very much.
Thank you.
Thank you
What a
very much for
wonderful
your
talk. Nice to see a robot that's seaworthy.